Hi, I'm Augusta Norzwiller Robinson, and this is my science fair project on mycofiltration, using Pleurotus Ostreatus to remove pollutants from residential runoff. My interest in water filtration began during a BWCA camping trip, and I came up with the idea for this experiment after my mom took me mushroom foraging and I read about microremediation, how mushrooms are being used to improve environmental problems. A problem that concerns me is residential runoff. It pollutes the Mississippi River and our 10,000 lakes, harming aquatic life. In fact, back in 1984, a study by the Minnesota DNR discovered waterways across the state were at risk of becoming too acidic for fish. Last year, Bear Creek, Heron Lake, and the Beaver River all appeared on the impaired water list due to poor pH. The purpose of this experiment was to see if mycelium from a mushroom that grows wild in Minnesota can be used to filter out plant fertilizer and road salt from water. That mushroom is the Pleurotus ostreatus, more commonly known as an oyster mushroom. To start, you should know that a mushroom is like the fruit of a fungus, while mycelium are like the roots of the fungus. To feed itself, these roots release enzymes that break down and eat away organic material, like wood, as well as organic pollutants like petroleum and oil spills and plastics. My hypotheses for this experiment were if the mycelium of Pleurotus ostreatus is added to polluted water, then the quality will become overall healthier for aquatic life. If the mycelium of Pleurotus ostreatus is added to polluted water, then the water quality will become overall less healthy for aquatic life. And if the mycelium of Pleurotus ostreatus is added to polluted water, then the water quality will not change at all. To do my experiment, I made 2 batches of an ice melt solution called IMS and 2 batches of a fertilizer solution called FS. I made the solutions by mixing 48 grams of ice melt with 4 quarts of water for the IMSs, and for the FSs, I mixed 4 quarts of water with 48 grams of Miracle-Gro fertilizer. I then put these solutions into their own bins labeled FS1, FS2, IMS1, and IMS2. To make the mycofilters, I cut the mycelium block of a North Spore grow kit into 6 pieces, 2 for backup, with a handsaw, and then wrapped them in window screen. I called these mycofilter dumplings. Once all the mycofilters were made, I placed one into each pollution solution bin. After 3 days, I would test 17 parameters for each bin and record the information on the project board I had hanging up. I would then wait another 3 days before testing. I did that 4 times. After I had finished the experiment, I recorded all the data into Google Sheets and created graphs showing the change in the parameters over the 2 weeks. I also researched the effects of all the parameters on aquatic life. I then picked 4 of the parameters which are the most important to the survival of fish. These 4 are pH. The pH of water affects the health and reproduction of fish and other aquatic organisms. Most fish thrive in water above pH 6.5. The mycofilter brought the pH from a deadly level to a thrivable level on the FS trials. Alkalinity works like a shock absorber that keeps the pH in water from changing drastically. The desired level of alkalinity is usually between 50 and 150 ppm, parts per million, for a freshwater pond. In both FS and IMS trials, the alkalinity rose for the better. Chlorine. High levels of chlorine burns fish and kills turtles, frogs, and aquatic plants. To keep these organisms safe, chlorine levels should be kept as low as possible, close to zero. In IMS, the chlorine lowered from a lethal level to a survivable one. Phosphate is the outcome of decomposing plants and other waste in bodies of water. Too much of it leads to algae blooms, which leads to lower oxygen, resulting in fish kill. Sadly, in both the FS and IMS, the mycelium couldn't fix the phosphate, but luckily there are already ways to filter phosphate out, like in Seminary Pond, a pond near my house, which is using an iron enhanced sand filter to get rid of phosphate before it gets into the Mississippi. This experiment showed that hypothesis 1, if the mycelium of Pleurotus ostreatus is added to polluted water, then the water quality will become overall healthier for aquatic life, is correct, because the mycofilter improved the water quality in all the bins. In conclusion, The mycelium of Pleurotus ostreatus, oyster mushrooms, can and should be used to filter out common urban pollutants like plant fertilizer and road salt from runoff. Thank you for listening to my science fair presentation.